Very good afternoon. This is Alok Srivastava from Network Nuts. So, as promised, a new video in a very short gap. So, this is a very interesting video, and actually, I should be saying thank you to our clients from Singapore. Like we have some students from Singapore, and we are conducting trainings for them. Obviously, the online trainings. So I was explaining them the concept of NTP, and fine, like fair enough as far as your RHCE is concerned. Whatever is mentioned in the books, all said and done, everything is fine. But these guys are really very smart. They're working with a very big organization there. I cannot disclose the name, and handling a damn huge data center. So they asked me how NTP works. Like, the question was not that fine, you go to it, if you're working on RHEL6, then you go to etc ntp.conf, write server and the IP address, and if you're working on RHEL7, then you go to etc chrony.conf and give the IP address, and your machine will go onto the internet and will fetch the time, and then your time will be adjusted. Their question was much more. The question was how exactly it works. Something like when we learn about DSCP, we have to learn about DORA, the mechanism in which the DSCP works. So the same thing, the same question was being asked, that how it works. So here goes the video, so that everybody of you will be benefited from their questions, and I hope I will be able to answer that question. And for those who don't like have the question itself in the mind, so it's a ready reference for the NTP. So let us go brief about NTP, and then I will explain it to you what exactly happens. So I'm just opening a gedit, my editor here for you. Just a moment please. So here it is. So it is NTP deep inside. So a couple of very a review of the NTP is that the purpose, what is the purpose of the NTP? So the purpose is very simple: to synchronize the clocks. I hope the font is visible. Synchronize the clocks of a server constellation to UTC. That is the main job. Synchronize the clock. That is right. Where it is used, utility. Everywhere the timestamps are used everywhere. So timestamps are used everywhere, like starting from log files to your banking applications. Everywhere the timestamp is used, right? And like your airline industry, timestamp when the transaction has happened, it's very important. And what kind of packets are exchanged. Sorry. So those who have already done the RHCE or same level of knowledge, they know that the NTP works on the use the UDP protocol, and port number is 123. So if your firewall is on, you need to make sure that this port should be allowed, right? And it uses its own binary format. I'm not going into that binary format, just a reference that if you wish to learn about it, please refer RFC 1305 and RFC 2030. I'm not going into that, but it is, they use their own binary format. And what kind of packets are exchanged? So there is a two-way communication. One, you have got a client, and one you have got a server, right? So the client, okay, I can write here packet exchange. First is the packet send. What packet is sent? So the first thing is that I'll do like this, that the client send the request with its timestamp. Fair enough. Now it's now the duty of the server to respond him back. So I'm just changing the direction of the arrows here, beautiful arrows. So now server return the packet with 3 timestamps. Wow, this is something new. 3 timestamps. What are these 3 timestamps? Sorry. Number 1, the echo of the client timestamp when the client has sent the request. If I am the NTP client, so when I had initiated the request to the server that I want my time to be synchronized, so echo of the client timestamp, that when you had given me the request. Second, when did I here means server, when did I receive the request? Because you are working on internet, it's not at all possible on the internet that the communication is on the via speed. There are latencies and things beyond your control over the like internet. You might have a say 100 Mbps of connection, but still some kind of latency must be there, or it is bound to happen. And the third is, when did I here means not Alok Shrivastava, I here means server, when did I send the response? So once the server has received the request, he might take some time to respond the client back. I'm busy, you are asking me some question, I'm busy, I will take my own time. Right now these types of packets are sent, and then what happens? Okay, I can write it here, I can just mark it here like this, so that will be easier for you. Yeah, that makes sense, it's look beautiful. Then what happened? The client then estimates the offset of time, the difference between him and the server. The client can have many servers, remember this. These are the basic building blocks, these are the basic knowledge that you should have for NTP. But the client will only choose one NTP. Client choose only one NTP server to sync the time, right? And to minimize the offset, and it then minimize with the offset. I'll tell you how. It then minimize the offset and skew with the time difference, skew with feedback loops. So it is what kind of packets are exchanged here. Let me make it more interesting here. Let me highlight it like this, underline it, so that will be easier for you to remember. Now these things are not there in your standard courseware in RHCE or everywhere else. They just teach you how to configure yourself as NTP client. But as an admin, as a person who is curious, you should be understanding what kind of packets are being exchanged, and I'll be digging on it more. Okay, so that is it. And as far as the NTP is concerned, it's the traffic is minimal, means that packet size that it exchanges, it's a very small size of packet. So I'm like exchanging with you or sharing with you a very interesting data here. Network use of NTP, as per the estimate, there are thousands and thousands of NTP servers here, or say thousands of NTP servers, and thousands and thousands and thousands of NTP client. So how much traffic they are generating over the internet? Just because every client is requesting to the NTP servers, please give me the true time. So the packets are very slow. So just note down these important points. The pair of very small packets at every 64 to say 1024 seconds are being exchanged, seconds for each server. This is the size, the frequency here, and there is a very new feature here, and as per the estimate, only 0.01% of the world traffic on internet is of NTP. So it is something like less than 5 GB per day. And I think I'm written a very huge size here. Okay, sir, say less than 5 GB per day. So it is not putting that much of load or congestion on the internet. And one very interesting thing in RHEL7 that now we use, like say I'll write here NTP with RHEL7. This is what the major focus is. So we now use like the latest version is NTP version 4 v4, right? And another thing is that we have got a feature of iBurst there. I can write here, or I can write in the network use. Okay, I'll just mention here the speed of communication between NTP client and NTP server will be 8 times more if burst keyword is used. What is this burst keyword? Let me show it to you. If I open my machine here, and you need to make sure that if the NTP is working here, the very easiest way to find out is there's a command there, time date CTL. So if you see there, by default my NTP is enabled, by default it is there, and NTP is synchronized, means the time is being, my machine is getting the true time. But from where it is getting the true time? I hadn't configured anything, I had just installed the machine. Fair enough, a very good question. And another thing that you should be aware of this, that you should check the status of the chrony service. Chrony D, either write chrony d.service or write chrony D, it makes same. So make sure it is active running and that it should be enabled. That means it is available across the reboot. Fair enough. Wow. Now the main configuration file in RHEL7 is chrony.conf. In RHEL6, I'll just write here, in RHEL6 it was etc ntp.conf, those who remembered. So here it is. So by default it uses these predefined servers by Red Hat. And see here, iBurst keyword is used now. It is not there in RHEL6. That means when I will be communicating with these servers, as I am communicating for the first time, please attach the NOS, like our Fast and Furious. Please initiate the NOS, or please start the NOS in my communication. So my communication between the server and the client will be 8 times more if I remove this iBurst option. So let it be there, no issues. So this is the information here. So means my machine is getting synced from these sources. How can I check? This is a very simple command, chrony c sources. See here, these are the locations from where I am getting my true time, and this is the Stratum 2 server, which is very good. And if you wish to learn more about it, just increase the verbosity here, so it will give you much more detailed information here, like this, right? So that if the star is there, that means it is currently synced, need not to worry, right? If it is a caret symbol here, that means it's a server, not a peer. Peer will be reflected by a is equal to symbol, and the information about it, that when it has been polled and reached and the last sample. I'm just avoiding all this thing here. I will be focusing on how actually the communication happens, how my machine adjusts its time when it gets a request or it gets a response from the NTP server. Fair enough. You can change the server, like suppose right now I'm getting the IP, the time from this machine. I don't want this server. I want to use another server with a higher stratum value. So I'll just show it to you. It's very easy to find another NTP server. They are freely available across the world. So I open my browser here. let it be the size so that you'll be. So I open google.com, the lifeline of all admins. Thank you Google for saving my life and whatever. Okay, just write here IP address of NTP server. So the most trusted resource is NIST time servers here. I always choose these IPs, and they give you a list of the NTP servers freely available. Okay, let me choose this one. I don't know which stratum it is right now, so I just copy this IP address, and you should remember the name is nist1-pa.ustiming.org. fair enough. Now I go to vim etc chrony.conf. I removed all these. I don't want these, that I should be using these as my reference. So I write my own entry server and I paste it. That's it, fair enough. Because I want a fast communication, so I should be using iBurst here. Save and come out as usual, and please restart the chrony. Wow, how can I be sure? Again, give the same command, repeat the same command, and it should now, instead of this, you should be getting your IP address. Let me check. Crony sources. Look here. Wow, that's great and wonderful. This is a stratum 1 server. That means it's a more trusted source. It's a more trusted source. And look, the same means now my machine has changed its location from where it was earlier, taking the time. That is what they teach you in the books, how to change it. But what happens? How the communication has done? What kind of packets my machine has sent? How the server has responded? How they have adjusted for the delay of time that happens during the transit? What is this? How this has happened? Now we will be focusing on the actual story. So let me go back to the, but right now everything is working fine. I'm getting the right time, everything, universal time and the IST time. NTP is enabled, NTP is synchronized. Wow, that's great. And there are a couple of more commands there, like crony, if I'm not forgetting it. Crony, sorry. Crony C, and if you want to help, just write heaven help here. So see here, host name, port number, and the command. So if I give a man crony C, there are a couple of options that you can use. Conf file, crony D, check the crony D here. Right, so I'm just avoiding that thing. So now the machine is getting the time from this stratum 1 IP address. But what happens behind the scene? How actually everything happened? So let us understand about this. So I'm back with my notepad, or gedit, sorry, not notepad. Okay, so let's give a blank space here, give some beautiful hashes, something like this. Now how it works, let us understand this now, how it works. Couple of very interesting points. Number one, you should know that NTP is actually being idea by Mr. David Mills. He's the guy we should be thanking for NTP, and he has done this project way back in 1985. So he's the guy who created this. So thank you, Mr. David. It is based on Marzullo's algorithm. But actually this algorithm is used only by a high stratum servers to get the accurate time. So it is not used by the clients. So I'll just mention it here, but it is used only by high strata servers to get accurate time using several sources. Remember, using several sources. So, but a client only use one source. Here, source means the server, not the peers. Right? So I can mention here, but normally a normal client on a normal day will use only one server. I hope you will agree. So how it used? Now let's start the working. So what happens is that now another thing you should understand, NTP time is not being stored or sent in actual MMDDYY or YYMMDD or YYDDMM format. NTP timestamps are used in seconds. So first point that you should remember is that NTP timestamps are stored in seconds, and a very interesting thing here is that the seconds are calculated since 1st January 1990. Remember that the year cal command uses the date or epoch format since 1st January 1970, but the NTP starts its number of seconds since 1st January 1990. Fine. And the timestamp is actually I can write here, timestamp is actually a 64-bit in size, and from this 64-bit, 32-bit is for number of seconds and 32-bit is for fraction of seconds. So what we had learned is that when the client initiate the communication, as I had mentioned there, like this here, client send the request with the timestamp. So he is sending his timestamp, which is calculated in number of seconds since 1st January 1990, and which is a 64-bit in size. Of that, 32-bit is the number of second and 32-bit is the fraction of second. Wow, this is new. Now, so total is 64-bit, right? So client, now why I use NTP? I'm using NTP because I think my time is not the correct time. So means I consider my time as wrong time and the server time as the true time, right? So I'll just write here, client time is say wrong time and server time, server here means NTP server, I'll write here, time is true time. So because the client has got wrong time, he need to recalculate or adjust his timing as per the response given by the NTP server. So how it works? Okay, let me assume here that say the steps involved. Very interesting point. Number one, because I am in need of the true time. So client, I am the client send the request at wrong time. I am the client and you, yes, exactly you, yes, you are the person, you means you who is viewing this video. So client send the request at wrong time, right? Say wrong time is, say it is 13/12/12/00. Okay, just to make it easy, I make it say time is 100. So let me give it a value here. So I say A equal to 100. A is the wrong time. So client has sent the request at say 100 time when the time is 100, right? Now because of internet connectivity, right, you will agree, it's not at all possible that the server will get this request at 100 time at the, like the time is 100. So there must be some latency, some couple of seconds. So server say Let us assume that server get the request at true time, means the server time. Let us say true time is at say 150, right? So that means, okay, let me write it here, it will be interesting here, like this. A is 100, right? Okay, so the now the server get the request, say the time is x equal to 150, means client has, okay, let me convert it in seconds. Client has sent the true time request at 100 seconds. Because of internet connectivity, just picture this, because of internet connectivity issues, server will get the request after after some amount of time, some number of seconds. It is practically not at all like not feasible and possible that I had sent you the request at 100 seconds and you received the request at 100 seconds. There must be some delay, right? So server has received the request at 100 seconds, right? That's great. Now third point, server might be busy, you are busy catering in to some other client. So I can write here server might be busy, so it doesn't send out the response, let me, until the true time, right? Until I say right here true time, let me give the time say at 160, means server, he has received the request at 150, but because he was busy, he will respond you back, but at 160 seconds, right? So I make it a value here, y equal to 160. So I've got 3 values by now. Me, the client has sent you the request at 100 seconds. Because of internet connectivity, you received my request at 150 seconds. Because you are busy catering to other clients, you have responded to my request at 160 seconds. This is a very fair and practical scenario, right? Okay, now fourth, you have sent me the request, but again the internet connectivity is here, because, so I'll write here, again of internet connectivity, client will get the request at wrong time. Wrong time means wrong time, very simple. Say he has received the request at 120, means the client clock was saying 120 when he has received the request. So the client clock was saying 150. So let me give it a value again. It's going to be like school maths. So let me give it a value b equal to 120. Now picture this. Client, when the client clock was saying 100, he has sent the request. But because of internet connectivity, the server get the request when his time was 150. But because server was busy, he has responded back at the time 160. Because of internet connectivity, the client get the respond back from the server when the client time was 120. So means 20 seconds has elapsed, but there is a time difference. When the client was at 100, the server was at somewhere around 150. Okay, now how the client will determine the time, that is the story. Client determine the time spent on the network. This is all in the algorithm. You need not to worry about how the client will calculate how much time is spent by the packet on the network. So there is a simple formula there. So b minus a minus y minus x. It is how, that means guys, that means b is 120 minus a is 100 minus y is 160 and x in my case is 150. So that comes out to be, for me it is 10 seconds. So means 10 second is the time over which the packet was on internet. Now, sixth step, the client assume, but this time is the time for the packet to go to the server and coming back, to and fro time. So then a client assume that time it took for the response to get from server to client is what? It's very simple, just 10 divided by 2. So this comes out to be 5 seconds because it's a to and fro traffic, right? Now 5 seconds is the time that it took the response to get from server to client. Means when the server has sent the request and the time by which the client has received, there is a latency of 5 seconds. So 5 seconds it took for the packet to come from server to the client. Wow, making maths again very difficult. Oh my god. Now the client will do what? Client will add that time to the true time when the server send the response to estimate that it received the response at true time. So what the client will do? So now the client will add that time to the true time when the server has sent the response. So server has sent the response at 160. So that, and so now the client is supposed to add 5 seconds into 160. So that means it is going to add 160 plus 5, right? That for me, I'm not very good in maths, comes out to be 165 seconds. Right? Now the client knows. Client now knows that he need to add 45 seconds to its clock. 45 seconds? How 45 seconds? Why 45 seconds? Look, the client has received the request at 120 seconds. But the time that he has got is 165 seconds. So if you subtract the true time or so what you need to do, you need to subtract the time at which the client received the request from the server and the estimated times, right? 165 time in step number 7. So what it comes that he need to add, so 165 subtracted by 120, so 45. So he need to add 45. So that means 165 minus 120, that comes out to be, for me, I think it is 45 seconds. That means there is a difference of 45 seconds between the client clock and the server clock. So the client will add 45 seconds to its clock. So it is how the NTP time is calculated. So the client will automatically increase its clock by 45 seconds, right? So it is what has happened when I'll just go back here. When I had configured myself as NTP client and when I had started this service. So that all has happened. So I will give crony sources, that's it. So this is all has happened in the background when I had given that command. And one more thing, if you go to the chrony.conf, there is something known as the drift file. You should also understand what is a drift file and how it records the gains and loss in time, right? So let us understand a bit about the drift file. If you know, the location of the drift file is var lib chrony drift. So if I see this file var lib chrony drift, it contains this time 4.35 and 4, so it's a positive value. Let me write this number. It is 4.35 something, right? 4.359. okay, I will close this. 4.359. I'm opening my gedit again. So let us understand. So it is how the 8 steps are very important for you, how the actually the NTP calculates the time. Now let us understand a bit about the drift file. A bit about drift file. What is the drift file? Right? So drift file happens. So why a drift happens? So the reason why a drift means a deviation, right? A drift happen when your hardware clock is either fast or slow compared to reference clock. Reference clock here means NTP server clock, because look, it's all about the crystals and the oscillations. NTP server, right? So only then the drift will happen, right? But as we are using NTP version 4, I had already told you. So normally it can, NTP version 4 can accurately keep your clock in up to 233 picoseconds, and believe me, it is a very good accuracy. I can write here, accurately keep clock within 233 picoseconds, right? And okay, if I go back to my file here, so it's a positive number, right? 4.359, fine, it's a positive number. So you should understand this thing also. So if it's a positive number in drift file, that means your clock is fast as compared to the NTP clock. Your clock is fast as compared to reference. Reference means NTP server. And in case if you find a negative value here, if it's a negative number in drift file, that means your clock is slow as compared to reference clock. You should be knowing all these small things, right? And number there is measured in parts per million. So that is not 4 point some seconds. It is not seconds. It is parts per million. It is not second. This is not 4.359 seconds. It is parts per million. Oh my god, this is nonsense. How can I calculate in seconds? Whew, this is difficult. I'm not going to continue more. Okay, let me continue and explain it to you. So remember, number in drift file is measured in ppm, or you call it parts per million, right? Now I've got a problem. The problem is that, let me put a lot of question marks, how to convert it into seconds. And believe me, I'm not good in math and still I'm doing this. Crazy. Lot of question marks here. So, okay. A very simple maths here. Look. Rule number 1. You should remember, there are 86,400 seconds in a day. Fact number 1. Okay. 86,400 seconds in a day. So to convert it into ppm, what I do, let me put it like this, it will be more easy, right? Yeah. So that means how many parts per million. So I say 86,400 divided by million, means ones, tens, 100,000, 10,000, lakh, million. Yeah, 6 zeros. Right. If I'm not wrong. Yeah. Okay. So for me, this comes out to be 0.0864 seconds parts per million, right? So if you calculate in ppm, so it is this value. So my drift file was showing what? My drift file was showing a value of, sorry, I forgot the value. Let me go back and check it again. 4.359. 4.359. So my value was 4.359, right? But this is in picoseconds. This is in ppm, parts per million. This is parts per million, ppm. How can I convert it into the seconds? So okay, that means this value tells me that means my machine is fast by 4.359 ppm, parts per million, compared to my time source. Fair enough, but please convert it into seconds. So now please convert it in seconds, so it will be more human readable. Okay, so what I do here, I just 0.0864 multiply by my value is 4.359. So that comes out to be, I don't know, let me use my calculator. If I open my calculator here, so that means 0.0864, right, multiply by, what was the value? 4.539. So multiply by 4.539, 0.39 seconds, 0.393 seconds, whatever. So that means my machine is roughly fast by 0.39 milliseconds as compared to my reference. I can write here 0.39 milliseconds, right? So that means roughly my machine is fast by 0.39 millisecond as compared to my time source. I hope you understand these things. So whenever you configure NTP, so it is when you just give the server IP address and just start the service, it is all that happens in the background. I hope you understand these concepts and just try to see on your machines how the things works and how the NTP works. So it's a very small effort of explaining you how NTP works deep inside. So thank you very much for seeing this video. God bless, and I will be back again with some couple of more very interesting videos. Thank you very much. God bless. I'm stopping the video now.